and let's see how we can do some curve fitting. So if you go back and review what we had before, we were able to do a plot, and what we're interested in is finding a formula for a line that passes close to, not necessarily through, all these data points. So maybe a line that sort of looks like this. Okay, so let's find out how to do that. If we go and look at the chapter readings, it says, well, what you should do is to figure out how to use the curve fitting operation. So let's see whether we can do that with the Maple help. It's usually a good place to do. Now it said type in least squares into Maple help, which I've already done, and you see these lists of things, lists of topics, and if we click on the curve fitting least squares as the directions indicate, we see that, well, let's look at the examples. Okay, so for example here, what you do is you say with curve fitting, and then you give a bunch of data points, and what you get out is a formula, which evidently is the formula for the line which passes close to these data points. So let's see whether we can just reproduce something like that. Okay, so first of all, let's go back to the worksheet and see whether we can get the help window to give us a little help here. So it says to do two things. One is to do this instruction, which loads the curve fitting package. So let's copy that out of this and paste it into this. We'll go into math mode and then paste in the expression. So we see that when we do this, it's silent. Nothing seems to happen. If we remove the colon, then we see actually what happens is that the result is we get this indication that all these different operations have been loaded into Maple. So the purpose of the colon is really to just suppress the output of a particular operation. So we'll suppress the output, and now let's go back and look at an example. So we'll just say, okay, well, can we get this to work at all? Let's see whether we can just copy this expression in and see whether we get that. And sure enough, we get what we want. Now, we are actually given this actual data, and this doesn't seem to be exactly the format that we want. So let's go back and look at help again. And this seems to be more like what we want, right? It turns out that when we look at the directions a little bit, the first example is really the least squares operation in this form, where all the x and y data are moved together. But the second form of this procedure seems to give the x and the y data as separate lists, which is what we're interested in. So for example, we could do something like this. Let's just see that we can get that to work. So go back into our little worksheet. Let's just write over what we have here. Let's paste in this. And we do get the answer. That seems to be fine. We can just double check to make sure that it's the same answer as what we had before. And yes, it's the same as the help. So that seems to be working. So we have to now figure out how to actually get it to work for this data. And when we look at it, it turns out that we have to do a little thinking here. It's evidently we want to use the independent variable here and the dependent variable as the second list. Right? That's what the documentation says here. And then v is supposed to be the name of the variable that we get in the formula. And then there's this weight, and actually in our situation we don't really have any weight, so we're going to ignore that part. So let's attempt to provide a slightly different version of the problem. We're going to say that the independent variable is temperature, and the dependent variable is pressure. Now the reason why we're going to do this is because we really want a formula involving T, the temperature. So let's say T is supposed to be the independent variable. So what we're expecting after we hit enter is that we're going to get a formula involving T. And we don't need any weights for this problem. So let's hit enter and see what we get. Okay, so we have our formula from curve fitting, and now we would like to understand that result compared to our original data plot. So let's go back and give this result a name. Let's call this fitted line. Okay, so if we want to plot the fitted line, then we just say, okay, let's take that expression and plot it between 0. We have to make some sort of decision about the upper end of the range. Since our independent variable t is between 0 and 100, let's make this go between 0 and 120. All right, so now we have a fitted line. We want to compare this to the data here, and the ideal situation is to have some sort of plot where both of these things appear together. So we want a single plot where this picture appears and this picture appears. So if we look at step 6, it basically suggests a fast way of doing this. So what we can do is take the original plot of the points from our worksheet and copy it into the other worksheet, and we'll paste it here. And then it says take this, make a copy of it, and then just click on the other plot and paste it, and we'll see what happens. Okay, so it isn't incredibly beautiful, but you can see that it really does combine the two plots together. Now in a week or so, in a lab or so, we'll learn better techniques for combining these two things together. The picture will look even better. But this does the job in the sense of convincing us that the formula for the line actually does pass close to all the data points.